According to the 2017 National Electrical Code, specifically Section 210.11 laundry areas must have at least one receptacle outlet on a 20-amp branch circuit. However, this section does not prohibit the use of two duplex receptacles on a laundry circuit, provided the total load does not exceed the circuit's ampacity. The primary concern is whether adding the home automation control panel to the existing laundry circuit will overload it. It's crucial to verify that the total load in the laundry circuit, including any existing appliances and the control panel, does not exceed 80% of the circuit ampacity, which translates to 16 amps for a 20-amp circuit. You should also ensure that the control panel meets the electrical requirements for the circuit in terms of voltage, amperage, and ground fault circuit interrupter protection if applicable. Before proceeding, assess the current load in the laundry circuit. This involves identifying all appliances connected to the circuit and determining their amperage draw. Check the nameplate on each appliance to find its power consumption in watts or amps. If the power is listed in watts, divide the wattage by the voltage, typically 120 volts in a residential setting, to find the amperage. Add up the amperage of all devices connected to the circuit. Then determine the amperage draw of the home automation control panel. This information should be available in the panel's documentation. Add the amperage of the control panel to the total amperage of the existing appliances on the laundry circuit. If the total amperage is less than 16 amps, connecting the control panel to the existing laundry circuit is likely acceptable. If the total amperage is close to or exceeds 16 amps, it is recommended to install a new dedicated circuit for the control panel. Now, let's discuss ground fault circuit interrupter or GFCI protection. While GFCI protection is not explicitly required for laundry circuits according to the NEC, it might be installed for additional safety. Determine if the existing laundry circuit is protected by a GFCI device. If it is, ensure that the control panel is compatible with GFCI protection. In the event of a ground fault, a GFCI device will trip, cutting off power to the circuit and preventing electrical shock. Regarding the two duplex receptacles on the laundry circuit, this configuration is not inherently a code violation as long as the total load in the circuit does not exceed its ampacity. The NEC requires at least one receptacle outlet in a laundry area, but it does not restrict the number of receptacles as long as the circuit's capacity is not exceeded. When communicating with the customer, transparency and clear explanations are essential. Explain the NEC requirements for laundry circuits and the justification for using the existing circuit for the control panel. Emphasize that the total load in the circuit must not exceed 80% of its ampacity and that the control panel must meet the electrical requirements for the circuit. If the customer expresses concerns about using the existing circuit, offer the option of installing a new dedicated circuit for the control panel. Provide a clear explanation of the costs associated with installing a new circuit. In the event that a new dedicated circuit is deemed necessary, follow these steps. Firstly, determine the appropriate amperage for the new circuit. A 15 amp or 20 amp circuit is typically sufficient for a home automation control panel, depending on its power requirements. Secondly, select the appropriate wire gauge for the circuit based on its amperage and the length of the wire run. Use the NEC tables to determine the correct wire gauge. Thirdly, install a new circuit breaker in the electrical panel for the dedicated circuit. Ensure that the circuit breaker is properly sized for the circuit's amperage. Fourthly, run the new wiring from the electrical panel to the location of the control panel. Follow all applicable NEC guidelines for wiring installation. Fifthly, install a new receptacle outlet for the control panel. Ensure that the receptacle outlet is properly grounded. Finally, test the new circuit to ensure that it is functioning correctly. Use a multimeter to verify the voltage and amperage of the circuit. Regarding the customer's concern about the additional cost of a new circuit, provide a detailed breakdown of the costs involved. This may include the cost of materials such as wire, conduit, and a circuit breaker, as well as the cost of labor. Explain the benefits of installing a new dedicated circuit, such as improved safety and reduced risk of overloading the existing laundry circuit. Remember that adhering to the NEC is crucial for ensuring the safety of the electrical installation. Failure to comply with the NEC can result in electrical hazards, such as fires and electrical shock. Always consult with a qualified electrician if you have any questions or concerns about electrical work. In addition to the NEC, local electrical codes may also apply. Check with the local authorities to determine if there are any specific requirements for electrical installations in your area. When working with electrical systems, always take appropriate safety precautions. Turn off the power to the circuit before working on any electrical components. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools to prevent electrical shock. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Let's delve deeper into the specifics of load calculation for the laundry circuit. Firstly, identify all devices that are regularly plugged into the laundry circuit. This may include a washing machine, a dryer, an iron, and other small appliances. Secondly, determine the amperage draw of each device. This information can typically be found on the appliance's nameplate or in its user manual. If the power consumption is listed in watts, divide the wattage by the voltage, typically 120 volts, to find the amperage. Thirdly, for appliances that cycle on and off, such as a washing machine or dryer, use the rated amperage for the appliance. This is the maximum amperage that the appliance will draw during its operation. Fourthly, for continuous loads, such as a lighting fixture, multiply the amperage by 1.25 to account for the continuous nature of the load. This is required by the NEC to prevent overloading the circuit. Fifthly, add up the amperage of all devices connected to the laundry circuit, including the home automation control panel. If the total amperage exceeds 80% of the circuit's ampacity, which is 16 amps for a 20 amp circuit, it is recommended to install a new dedicated circuit for the control panel. Regarding the type of wire used for the laundry circuit, the NEC specifies that the wire must be sized appropriately for the circuit's amperage. For a 20 amp circuit, a minimum of 12 American wire gauge or AUG copper wire is typically required. However, the specific wire size may vary depending on the length of the wire run and the temperature rated of the wire. Consult the NEC tables to determine the correct wire size for the application. In addition to wire size, the type of insulation used in the wire is also important. The NEC specifies that the insulation must be rated for the voltage and temperature of the circuit. Common types of insulation include thermoplastic high heat resistant nylon, or THHN, and thermoplastic heat and water resistant, or THW. When installing new wiring, follow all applicable NEC guidelines for wiring installation. This includes using appropriate wiring methods such as conduit or cable, and properly securing the wiring to prevent damage. Also, ensure that all wire connections are made properly and are securely fastened. Loose or corroded wire connections can cause electrical problems and even fires. Let's consider the scenario where the existing laundry circuit is already heavily loaded. In this case, even if the addition of the home automation control panel does not exceed the 80% ampacity limit, it may still be prudent to install a new dedicated circuit. A heavily loaded circuit is more likely to experience voltage drops, which can affect the performance of sensitive electronic equipment, such as the home automation control panel. Voltage drops can also cause the circuit breaker to trip more frequently, which can be inconvenient. In addition to voltage drops, a heavily loaded circuit is also more susceptible to overheating. Overheating can damage the wiring and insulation, increasing the risk of fire. Therefore, even if the NEC allows for the connection of the control panel to the existing laundry circuit, it may be wise to install a new dedicated circuit for safety and performance reasons. Another factor to consider is the future expansion of the home automation system. If the customer plans to add more devices to the system in the future, a new dedicated circuit may be necessary to accommodate the additional load. Planning for future expansion can save the customer money and hassle in the long run. When discussing the option of a new dedicated circuit with the customer, be sure to explain the benefits of doing so. Emphasize the improved safety, performance, and future expansion capabilities that a new circuit can provide. Also, be transparent about the costs involved, including the cost of materials and labor. Provide the customer with a written estimate of the total cost of the new circuit. In summary, the decision of whether to connect the home automation control panel to the existing laundry circuit or install a new dedicated circuit depends on several factors, including the total load on the laundry circuit, the electrical requirements of the control panel, the presence of ground fault circuit interrupter protection, and the customer's preferences. By carefully considering these factors and following the NEC guidelines, you can make an informed decision that ensures the safety and performance of the electrical installation. Always prioritize safety when working with electrical systems. If you are not comfortable performing electrical work, hire a qualified electrician to do the job. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC and local electrical codes.